This video is part of my free NIST GCMS software lab for universities. This part concerns processing typical data files in the Chromatogram window. The overview includes processing of the EI GCMS typical files, which will only be a video, configuring and navigating Chromatogram window, NIST 26, and associated help files, and that'll only be in the handout only. Downloading additional EI data files, handout only again, and basic understanding of the operations performed in Chromatogram window. So a lot of this will be in the handout, and the primary demonstration of the software will be in the video. Configuring and navigating the Chromatogram window and the NIST 26 and the help files associated with it can be found in my instructional video tutorials and the associated handouts. And you'll need just to do that after you look at my demonstration video if you want to learn a little bit more how to customize the windows and understand some of the software. Downloading additional EI data files. I've supplied some additional demo files on my website, and it will be useful to download them so I can show you. I'll use a couple of them in the demo software, but you can find them within the resources. And I suggest you put them in the AMDIS tutorial folder just to be consistent with the ones that NIST supplies. In the next few slides, I'll give a basic understanding of the operations performed in the Chromatogram window. It performs deconvolution of the spectra. That's just a fancy way to say it gives you a good spectrum, correcting a lot of chemical noise, etc. Performs library search to yield the best library match. And this AMDIS engine that runs all this is called Automated Mass Spectral Deconvolution and Identification System. And it was originally a standalone application, but now they've integrated it into the NIST software. It'd be nice to understand how to use this, and you might want to come back and review these slides at a later date. But initially, you can just kind of think of the integrated AMDIS engine as the laboratory assistant working behind the scenes. Before you ever see a library search result, it has already cleaned the spectrum, removed background contamination, separated overlapping compounds, and extracted the purest possible spectra for searching. In NIST 26, you don't have to operate the assistant. You simply benefit from its work. And I go through trying to make you understand how this works. And you probably want to look at these at a later date. I won't go through them now. Talks about the ions. And it's got a nice figure when you get through. I think it'll kind of put it all together for you in a nice picture. So now I'll go on and do the software demonstration and leave this information for you to look at a later date. Well, we'll go open the program, going to the Programs menu, going to find the NIST 4 EI demo, NIST version 4.0. When you open up, the first thing you need to do is just to check to make sure you had the libraries in properly that we installed. So I'll go to File and Analyze EI Input File. Here you can go select the file that you want. I'll go to the tutorial files and I'll do the Grobe test mixture and open that. And now just to make sure the libraries are right, also you need to be Analyze No RI. Libraries, they're all there. I want to make sure if I hadn't installed it correctly, I wouldn't be able to include the libraries in this search, and just say OK, and then OK, and the file should run. It'll probably take about 5 or 10 seconds to run the file, and there are the results. So usually for filters and everything, I just turn everything off initially. The one that I like to keep on almost all the time is merge duplicate IDs. So a lot of times it might double mark a peak and you'll get more than one entry for it. Maybe this could be a problem here. So I'll just go up and put usually either like 1 or 2 seconds. You don't want to go too large because you might exclude the compound that has the identical spectrum of another compound because it's an isomer. So 2 is a reasonable value. So we've got 2 now. So now let's just go through what we see here. On the bottom are the results for all the entries. So I'm going to pick one of the peaks up here by just clicking on the little circle that shows that that's been identified or characterized, and that's une decame. So if you look at the bottom, it has the retention time. The score is, if it's greater than 800 or so, it's definitely a possibility. 904, that's definitely a reasonable possibility. And the other things are the relative abundance. you'll notice that the relative abundance, if you sort by it, runs from 100. So the peak with 100 here is the 100. Everything is relative to that. So it has, we'll just look at the identity of this one. If you go back to the other one we were at, here's one. So there's one that was identified. One thing they don't have when they first open up, they don't include the structure. And I really like that. So right click, go to properties and say structure on plot. And that's my default setting. I like to see that as I'm looking at the components. And then it also has other information like the databases. It's in. If it's in a lot of databases, that's a good indication that it might be a reasonable structure. And the databases, you can go up here, you can see which ones it's in. It's in a lot of different ones here if you scroll down and look at them. So I'm looking up here at the top. The other things you'll see here at the top is the unknown spectrum. Looks like it has molecular weight of 282, and the bottom is the best library hit. And in this software, you only get the best hit. You do not see the second hit, etc. We'll talk about how to do that later. But in this part of the Chromatogram tab here at the bottom, program we're in, it only gives you the best hit. Now, if you wanted to step through them, you could click on this peak here, and then I'm going to the bottom and selected one. Then I'm using the arrow keys, and then I can just step through them and look at them. I'll resort by retention time would be a better way. So we'll do the lowest retention time first. So I clicked on it twice to get the low one. Let's start here and just step through some of them. So you can use the arrow keys on your keyboard to step through them. It's easy to review the samples. But you notice we're looking at a lot of very small peaks. One way to get rid of those is this max to max to medium. And it's really just a filter by the lower peaks are removed. The lower the higher the number you go to, the more the little peaks are removed. So I just try one of those. 20 is a reasonable thing. So we tried 20. You can see it got rid of most of the small peaks, but didn't get rid of any of the significant peaks. Maybe that one right there. Let's go back up a step and maybe say 10. And see that one got that one back, but it picked up some other small ones. So it's a trade-off. The other way you can sort and find the biggest things is to use your keyboard, the shift and the control key, while you use the mouse. So let's go in and look at the highest abundance. I'm sorting by abundance, and let's look at the first one. I use the shift key to select it. I go down and let's look at everything above 1.10. So if I'm holding down the shift key, I can click on it. Now it selects all of those. If you use the control key, it just selects one at a time. But this gets arranged, and now you can say right click on that and say show selected. Now we got rid of a lot of the small peaks. And if you wanted to look through them now, I usually like to look at them left to right. So I would go to retention time, click on it twice, and I'll start right here and look through some of them. I will do this one too. So I'll start there. And now you can just step through them and look at the big peaks that way. So there's lots of ways you can sort things, and you can always reverse things if you want to. Nothing really ever totally goes away, so we can right click here and say show all, and it'll go back to the other display. So another way you might like to sort is look at everything above a certain score, things that have been identified. So again, I left click on the first one, hold the shift key on my keyboard, to select everything. We're going to select everything with a hit maybe above, oh, let's say 759. So I selected all of those and say show selected. And now you could just go through and step through the things that have been identified. So that'd be another way to look at things. So you can see there's lots of different ways to look at things. It just depends on what you want to do. But the things that I'd like to stress again, I like to use the 2.0 seconds to get rid of maybe peaks that are being marked more than once. And I use the max to medium type filter setting to filter things out. That's a good way to get rid of small peaks. And the other way is maybe sort by score, the highest scores, or you could sort by abundance. So depending on what you want it to do, it's easy to get down to the most essential components of interest and eliminate some of the smaller ones. So that's pretty much the basics for this nominal mass file using the chromatogram. I want to show you one that's a little bit more complicated, so we'll go to the next example. Before we go to the next file, I'll just go ahead and turn some of the filters off to make sure I don't use them and not be aware I'm using them. So I'm going back and say all to get rid of that filter for the max to median. So now it'll mark all the peaks. And you can see as we get rid of things, the hits go up. So this number up here has went on to 22. The other thing I'd like to do, just to see what the number was, I forgot to tell you about that number. Say show all. You can see originally the number of hits was 61 in the file, and it's always a good idea to keep an eye on those as you minimize things and be sure to open back up things before you change and maybe sort by score or the other thing was sorting by abundance. So you might not want to use the max to medium as a filter that's turned on when you use those others. So you might should set that on all. So let's get another file. We'll go Analyze EI Input File. I've added some other additional EI files, and one of them is the Agilent test file. And so I'll open it up, and you can see that I just decided just to put it in the tutorial. Didn't have to, but I just wanted to keep everything together. So I'll open that and say Open. And then just check the libraries again. They should be the same. I didn't change them and say OK. A little bit busier file, so it'll take a little longer to process this file because it has more components, but still pretty fast. You can see that had 124 components it found in there. There's a lot of very small peaks in here, so we might want to get rid of some of those. So maybe we'll turn our max to median on again, maybe try 10. I got rid of a lot, maybe 20. That's taken it down to 82. So we've gotten a lot small. Please just go to the maximum, 50. So I got the majority of the small peaks, and now we can look at the other major components. You could just step through them, but this file I really wanted to show you is because there are things that are co-alluding. And you can look at things by left-clicking and drag. You can see there's the two dots that are on top of almost each other there. You can see that it did not separate them with the chromatography. They had a very similar retention time as they came off the column. So this peak was butylbenzene, and the other peak was dichlorobenzene. You can see uh, the software does a very good job of resolving things that you couldn't resolve yourself. And you can see there are other components over here that are also co-alluding. Say undo zoom to go back to them. There's actually a lot of compounds in this folder. So I'll put this on the website. So it's a good one to try to see if you can deconvolute. But besides that, you can do all the things you could do before. You could sort by relative abundance if you wanted to, only look at the main things. Let's turn max to met off when we do that so we can see, make sure we get all the peaks. And then say show all, undo zoom. Now we can see everything. So we should see up to 100%. So that's the biggest peak right there. And you could just look again by left clicking, go to the shift key, and let's look at everything above maybe, oh gosh, let's say 2% here and say show selected. See, that got rid of a lot of the small components. And then you could just click on where you wanted to start, use the keyboard again, up and down arrows, and step through and compare as you look at them to see if the identifications, the unknown versus the library, looks reasonable. So very easy to do. The other thing you could do is look at things by score. So you could say undo, show all, could resort by score, but the things that are higher fit the top. So let's look at everything that maybe has a score above, oh, let's just say 900 and say show selected. And that'll cut the list down a lot too. If you just wanted to look at the major peaks, it got rid of some small peaks that we probably could have identified. But in general, that's how you do these types identifications or getting proposed identifications. You just bring the file in, select the proper parameters. Like I said, merge the duplicate, keep an eye on your hits as you cut things down. Decide if you want to look at the things with the best scores, the best abundance, maybe a narrow range just by left clicking and dragging, and you can see it narrows the list down that way. But like I said before, you can undo everything. So show all and just keep unzooming, undo zoom. And now we're back up to the 124 that we started with. So nothing's ever really lost. You can try processing it different ways to see what gives you the best information for what you're attempting to do with the sample. I wanted to point out one other thing that I had not discussed yet. There's actually two axes on here. The abundance is on your left, and the total ion counts, the number of counts that the detector determined for the different ions, is on the right. And the dot here is, of course, the abundance. So it's 100. If you click on the tallest peak, it'll be at 100. So you can actually show those two different axes separately. And to do that, you can right click and go to Properties and come over here where it says abundance. You could do a log scale on it. Okay. And now it kind of blows up the lower level components so you can see their relative concentration to each other. So that can be useful in some cases when you're looking at very small components and you're interested in those lower level impurities. I'll turn that back off, because normally I find it usually best to do linear for that, but just wanted to show you that capability. And again, I want to reemphasize, we've just been in the Chromatogram tab. When we opened up the files, we're just doing the processing, this integrated AMDIS within Chromatogram. There's a lot of other tabs here, and we'll discuss other ones and other parts of the videos because they're very important too. But this is the basic one that you need to know how to do for identifying unknowns in GCMS files. Good day.